All right, my name is Josh Saul from B Networks, and very glad to be here. So I'm going to be talking about using a SONiC abstraction API. Real quick, just background on me, been a network engineer architect for 20 plus years on the end user side with NBC Universal, GE, Pfizer, and then I jumped over to the dark side and started working for Cisco sales, mostly covering financials. Spent some time at VMware, also financials, and then I sort of made a pivot and started focusing on startups, open source networking, and network automation. And I got into network automation around 2001. I was using Perl to automate a Cisco 5500, and I don't know if anybody knows this, but those have incredibly small management planes, small CPU. This was 2001, so I'm automating this thing, and I find out that this is Telnet, I find out if you hit it with the wrong password via Telnet 5 times in a row, the box reboots. So that is what I like to call a resume generating event. So to dive right in, to answer this question, why haven't we seen full adoption of network automation yet? I like to say we haven't had good tools. We've had rough knives. We've had hammers when we needed screwdrivers. The vendors haven't been very supportive. Either they haven't given us the right software or the hardware was limited. So everyone in this room should really give themselves a pat on the back for working with some of these rough tools and learning how to sharpen them in these types of communities and in these forums. So I'm going to talk a little bit about SONiC, but for the people that are like, oh, it's a video game or it's a hamburger place. No, SONiC is software for open networking in the cloud. It's an open source NAS. It was created by Microsoft Azure, used in almost every hyperscaler. It's available on every hardware vendor, not every platform, but every hardware vendor supports SONiC. It is the future of networking. Please, if you haven't heard of SONiC, take a look at the SONiC community. This is very exciting stuff. So I'm just going to give you a quick example of what we did for one customer. They're a large government agency. As you can imagine, a few years ago, they were challenged by supply chain. They couldn't get switches in time, so they had to consider multiple vendors. And the great thing about SONiC is you can get hardware from all sorts of different vendors and run one operating system. There's a caveat there, right? And we're going to get into that. And what they need to do is basically what everyone in the data center needs to do. They have their physical underlay up, and they need to create multi-tenancy all the time. They're always creating new VRFs, new services, VLANs, VXLANs, routing policies, et cetera. They create that sort of design, and then they plumb it onto physical ports, Ethernet ports, 802.1q trunks. So they do this all the time, but sometimes they have to program a device either via gNMI or CLI or SNMP or some other weird reasons, weird methods. And why is that? Well, multi-vendor SONiC is not one distribution. It's one operating system that is customized for all different vendors. So while you can get a whole bunch of consistency by using SONiC, there are some rough edges. What are the rough edges? Well, this is what we were challenged with. There are different features and protocols that are supported on different boxes. There are different ways of programming each switch, each distribution, and specifically, I think what we're all talking about here is that we're not really programming individual devices anymore. We're programming fabrics. So when we make a change, it could affect a whole bunch of different devices, and it's hard to understand how those changes cause a whole bunch of devices to be modified and then perhaps restarted, or how can we minimize the effect of traffic? So what were those big problems? Well, they want to take those smaller objects, right, the VLANs, the VRFs, and they want to put them together into one large logical object so they can determine if there's consistency in their model to make sure that the VLANs are properly plumbed to a router, an Anycast gateway, providing DHCP relay services. They have to check that because they might create like half of it at one time, or somebody might make another change that invalidates the first change. So they want to sort of put things together. And using REST API, that's not the easiest thing to do, right? You're dealing with creating a whole bunch of different objects, and how do you deal with this larger object that you've created? And they don't want to know about the feature inconsistencies and the differences between devices. They just want this API to sort of spit out the outcome. And the outcome is the config. They want to see a config for gNMI and a config for CLI. And those are radically different if you've ever played around with gNMI and any of the non-CLI methods. So just so you're aware, this is what the split for these main vendors looks like. And while they all are gravitating towards gNMI, there are some differences here, and there are some weird things that you might want to turn on. And you actually need to directly access the Redis database. Now, I'm not saying that that happens regularly, but if you're, someone who likes to twiddle nerd knobs, that's how you have to do those things. So the protocol differences, the main ones you should be aware of are the fact that vendors that came out early and needed to provide server link redundancy had to go with MLAG. They had to create their own implementation of MLAG. Everyone knows that's not a standardized protocol. And other people who came a little late to the game had the option of waiting for EVPN and getting the benefit of ESI. Now, remember, the solution, the outcome for the customer is the same. They get redundant NICs to their servers. But the protocols are wildly different. And you may not know that in this particular area of the data center, you have devices that are from a vendor that supports MLAG, and over here supports ESI. All you care about is a cloud-like experience. You want a VRF, a VPC, a tenant that has networks connected to it, and redundancy down to the NIC level. Also, there's this concept, different ASIC vendors have this concept of reference design. One of them is east-west, the other one is scale-out. You can research those and see those reference designs. Okay, so what do we have to do? I said we had to batch together those objects. We had to use REST to create a whole bunch of small objects, put them together into what we call a change set, and then push that into the REST API and say, give me back those configs. And why do they want to see the configs? Because we know that we're not working in a vacuum. There are a lot of other tools that analyze configurations. There's SecOps, there's compliance, there's just sanity checks on configs to make sure that you're not putting the wrong stuff onto devices. So using that REST API, you get the configs, you put them into GitOps, and then there's some other there's another process for that approval. And finally, when the approval comes in, you can just push those configurations onto the devices. The CI/CD overview is basically what I just described, but it uses just a single REST API, a whole bunch of different endpoints, but one place to go in and say, I want this tenant, this overlay object, and tell me if I'm going to put it on these ports and these ports, tell me what the configurations look like on all affected devices. Give it to me back in JSON so I can put it into GitOps. And they wanted to do that with essentially a read-only mark point, a checkpoint on the devices to make sure that no configs were pushed onto the devices until they were finally ready. And lastly, once the change in GitOps is approved, they push read-write, the configs go on, telemetry gets enabled, the devices get discovered. This is what this single API endpoint looks like, and you can see that this is using gNMI with OpenConfig. So if you're a CLI person, you're like, what the hell is this? This is sort of the new method for programming devices, and admittedly, it looks pretty nasty, but there's a lot of reasons behind this sort of complexity. And when you use tools to decode this, it starts to make a lot of sense. Using the same API, a different device, like this is Leaf A2, one other device would be Leaf A3, and this device is a CLI device. So you can see just coming back from this one API, they get what's specific to that particular device, protocols, features, and all that. So just to wrap up, this is a lightning talk. When that goes off, I get struck by lightning. These are the main takeaways. And I think we've all we've heard the same things all week. Really think through the network model. Spend a lot of time, stare at it. Think through all the permutations of the different objects, okay? Plan for extensibility, hopefully using graphs so you can add more information later. Put facts about your devices and your device models and their features and capabilities into those objects. Try to write the feature support in advance so you can pop other devices in later. If you're just doing ESI, it makes sense to do MLAG at the same time. Just get it all done early. And lastly, it's really important to get that kind of dry run configs out of the system, out of the REST API, so you can analyze it elsewhere. Don't work in a vacuum. You have to talk to other systems. That was it. Thank you very much.
All right, thank you, Josh.